Good day, students. Welcome to mathgotserved.com. In this clip, we're going to be going over how to solve quadratic equations by completing the square. Alright, let's consider the following problem. We're to solve the given quadratic. By completing the square. Okay? So quadratic equation by completing the square. Okay, so let's say we have the following quadratic equation: x squared minus 8x plus 19 equals negative 9. Now, if we want to solve this quadratic equation by completing the square, we need to create a perfect square trinomial on the left side. Okay? The beauty of having a perfect square trinomial is that it can be factored into the square of a linear expression. Okay? So let's say we have something like this. So something you want to recall is that if you have an expression a squared minus 2ab plus b squared, this can be factored into a minus b quantity squared because it's a perfect square trinomial. If you have a squared plus 2ab plus b squared, this can also be factored into a plus b quantity squared because it is a perfect square trinomial. Okay, so what we're going to do first is we're going to isolate the first two terms, the ax squared and bx terms, and move the constants to the right side. So to do that, we'll subtract 19 from both sides, and that yields x squared minus 8x equals negative 28. Now, why did we just do what we did? We want to create an incomplete square on the left side so that we can complete it in such a way that it becomes a perfect square trinomial. Okay, so that's the goal. Now we are going to add a special term that completes the square. Okay, so there's a formula for completing the square. If you have x squared plus or minus bx, the final term that makes it a perfect square trinomial is plus b over 2 square. Okay, so we add b over 2 square, that completes the square. Okay, so now on the right side of the equation, what are we going to do? We are going to add the same value to the right side also. We're going to add b over 2 square, so we do not change the problem. Okay, when you're solving equations, whatever you do to one side, you have to do exactly the same thing to the other side to preserve equality. As you can see, we did that earlier by subtracting 19 from both sides of the equation. Okay, so what is b and what is a in this format right here? In this format, a is the coefficient of x squared, a is 1, and b is negative 8. Okay, so b is negative 8. We need to find b over 2 square. So we divide negative 8 by 2, which is negative 4. If we square that, b over 2 square is negative 4 square, which comes out to positive 16. So by inserting 16 into the quadratic on the left, we're going to have x squared minus 8x. We're going to add that 16. Guess what? We have created a perfect square trinomial on the left side by design. Okay? Now we added 16 to the left side, so we have to do exactly the same thing to the right, plus 16. Now that we have a perfect square trinomial, we can use a nice little factoring trick to factor that. If you look at the formulas that we have right here, if you notice that taking the square root of the first and the last term and taking the middle sign down gives us the factored form. Okay, so we're going to employ the same strategy here. If I take the square root of the first and the last term of a perfect square trinomial, bring down the middle sign, okay, and then that expression I get squared is the factored form of the perfect square trinomial. On the right side, we have negative 28 plus 16. That comes out as negative 12. Now, to get x isolated, we're going to use the square root property to get rid of the square on the left side. So what we're going to do is take the square root of both sides of the equation, square root of the left side and the right side. On the left side, since we have two inverse operations acting on one another, the square root and the square cancel each other out, and we're left with x minus 4. Now let's simplify the square root of negative 12. What does that become? Let's put that to the side since we have to do some work here. Square root of negative 12. Now that negative underneath the square root comes out as what? Remember that the square root of negative 1 is what? The square root of negative 1 is not a real number. This is I. So when you're taking the square root of any negative number, you always have an I component associated with it. So the negative right here that's been multiplied by 12 comes out of the square root as an I. Now we're going to decompose 12 completely, expressing it as a product of primes. Okay? So we take out 2 from 12, we get 6. 6 is composite, we can decompose it further. We have 2 times 3. So this gives us the prime factor decomposition of 12. It's 2 times 2 times 3. Now 2 times 2, these pair form a perfect square. If we take the square root of 2 times 2, the answer will be 2. Okay, so 2 times 2 comes out of the square root as a root of 2 times 2, which is 2. But 3 is not a square because it doesn't repeat itself in the prime factor decomposition of 12. So 3 doesn't have a partner to break out with, so it stays behind. The simplification of root negative 12 becomes the 2 that came out, the I, which was a result of taking the square root of a negative, and then 3 stays behind as a radicand because it doesn't have any partner, identical partner to come out with as a square root. Okay, so we're going to have 2I root 3. Now, anytime you take the square root of a square, you always have to add a plus or minus. Okay? Now, let's go ahead and get x isolated. To get x isolated, we're going to add 4 to both sides of the equation. So that gives us x equals positive 4 plus or minus 2I root 3. Okay, so let's go ahead and write our solutions in a separated form. There are two solutions here. So our solutions are the set. The first one is 4 minus 2I root 3. And the second solution is the sum 4 plus 2I root 3. Okay, so the split happens along this plus or minus sign. Is a combination of two complex numbers into one format. Okay, so we just separate them using the plus or minus. The first one is 4 minus 2I root 3, and the second is 4 plus 2I root 3, and that is your final answer for question number 1. Thanks so much for taking the time to watch this presentation. If you found the contents of this tutorial helpful in your study of quadratics, do give us a thumbs up. Your positive feedback is very valuable to us. If you have any questions or comments about the contents of this tutorial, just place your questions or comments on the comment section below, and we'll be more than glad to support you. Don't forget to subscribe to our channel for updates to other math tutorials such as this. More clips can be found on mathgotserved.com. Go ahead and check it out. Thanks again for watching, and have a wonderful day. Goodbye.